Okay, Bismillahirrahmanirrahim. Okay, regarding the mobile station, the GSM separates user mobility from the equipment mobility by defining two distinct components. One is the mobile equipment, that is the cellular telephone itself, or your mobile phone, as you call it, right? So that mobile phone actually has an address or identifier, that is the IMEI, the International Mobile Equipment Identity. So whenever you're going to buy a mobile phone that has some IMEI number associated with that particular mobile equipment, and then when you purchase your mobile or buy your mobile phone, then you have to insert some subscriber identity module inside that, right? So that is a fixed installed chip that is also exchangeable. For example, you can change your mobile SIM to some other network, or you can change your mobile phone number. Then obviously you buy some other SIM, right? So the addresses or the identifiers that are associated with the SIM are IMSI, that is the International Mobile Subscriber Identity, and the other one is the MSISDN, that is the Mobile Subscriber ISDN number, and that is basically your telephone number, right? So these are the two things that are associated with a mobile station. So I repeat, one is the mobile equipment or your mobile phone. So that has an IMEI number, that is a unique number. So obviously each one of you, if you are having a mobile phone, then that mobile phone must have some IMEI number associated with that. And then when you put a SIM inside your mobile phone, so obviously that SIM has two addresses associated with that. One is the IMSI, International Mobile Subscriber Identity, and the other one is the Mobile Subscriber ISDN number, that is also simply stating your mobile phone number. When we talk about the mobile equipment powers, that basically depends upon what kind of mobile equipment you are using, right? So there are different classes associated with that. One is a class 1, 2, 3, 4, and 5, and that have different maximum power or wattages associated with that, right? So that all depends upon your mobile phone. But you can see that the wattages is in, within the tens of watts, you can say, right? So it's not in kilowatts or megawatts. So obviously, this is a low power equipment, that mobile equipment. Okay, we talked about the IMEI number over here that is related to your mobile equipment. That uniquely identifies your mobile equipment. That is usually a 15-digit hierarchical address. And this is assigned to the mobile equipment during the manufacturing and type approval testing. So that is a time when that IMEI number is associated or given to your mobile phone, and that is unique as well, right? So the structure includes different number of you can say digits, and each group of digits has a certain uh, association, right? So for example, the first 6 digits is basically the type allocation code. Then the next 2 digits are the final assembly code. Then we have a serial number and a spare digit. So overall, these 15 digits are uniquely associated, and then that is provided to the mobile equipment. Again, as I say, that during the manufacturing or the testing process, it is given to any mobile phone, right? Okay, so starting from January 1, 2003, the IMEI structure was changed. And even after that, a number of times that IMEI structure is changed. And obviously, mobile phone are, you just, if you just type how many mobile phones are there in the world, so you will find that there are billions of mobile phones in the world. So obviously, you need to change the IMEI structure with time. So again, that is not something that we would be looking at in great detail, but obviously we need to know what IMEI number is. Okay, this is important, the IMEI management. So this is basically the protection against the stolen and malfunctioning terminals. The equipment identity register is basically something that is associated with IMEI. So we have to look, we need to look at this equipment identity register. So this is the thing, equipment identity register over here that we saw in the last lecture, that is basically, connected to the MSC. So in the MSC, in the mobile switching center, you have seen that there is equipment identity register. So this register basically is very important. So in this register, this is basically a one database for each operator, right? So for example, I'm using the Jazz Warid operator. So there is one equipment identity register associated with that. So that is one huge database, that is the equipment identity register. And in this equipment identity register, there are different kinds of lists. So the first list is the white list. So in the white list, there are valid IMEI numbers. So this corresponds to the mobile equipments that may be used in the concerned GSM network. And then we have a blacklist. That is the IMEIs of all mobile equipment that must be barred from using the GSM network. So the exception is the emergency call to a set of emergency numbers. The blacklist periodically exchange among different operators. So different operators also, exchange the list of this blacklist with the other operators as well, right? So mostly the law enforcement agencies, basically, they are in contact with the GSM operators, and they provide, the controversial or the people who are associated with the, bad activities. So their IMEIs are usually entered into this blacklist, right? And then we have a gray list, that is IMEIs that correspond to mobile equipments that can be used, but that for some reason, malfunctioning, obsolete software, evaluating terminals, need to be tracked by the operator. So a call from a gray IMEI is reported to the operator personal, right? So this is sort of a list that is, not as free as the white list, but this is also not sort of blacklisted as this blacklist is. So this is something in between whitelist and blacklist, where the operator usually keeps an eye on, and that is not, only related to the activities that are controversial. But for example, there are some kind of software upgradations, or you're evaluating something. So you may put some mobile equipments of certain areas, for example, into that gray list, right? So that gray list again is available in this equipment identity register. So that was all related to IMEI. That was the part of the mobile equipment. Now we're going to see the subscriber identity module, that is the SIM card, right? This SIM card is uniquely associated to a user. It's not associated to an equipment, as in the first generation cellular networks. That was, the early 1G systems, where the SIM card was uniquely associated to a particular hardware or the mobile phone. But that is not the case with the GSM and networks beyond that. It stores user addresses, the IMSI, the MSI, SDN, the temporary addresses for location, roaming, etc. Moreover, the authentication and encryption features are also included in the SIM. And there are subscriber secret authentication key, authentication algorithms are incorporated into this, and cipher key generation algorithm is also associated with the SIM card. The SIM stores user profile. For example, your mobile SIM is obviously associated with your, for example, your CNIC, right? Your government authorized identification. So obviously eSIM is allocated in the name of some person, right? So obviously it has a certain, storage available. There's the RAM that is available for SMS, short number, user directly. So whenever you purchase a mobile, so obviously that mobile has a large memory, but your SIM also has a certain memory. So you might have seen that a few of your numbers are sometimes stored in your SIM card, right? Moreover, the protection codes are also there, the personal identification number, the unblocking key. So there are a number of things associated with this SIM card. Then we have IMSI, the International Mobile Subscriber Identity, that uniquely identifies the user, right? That is a SIM card, the GSM specific address, right? So this is different from the MSI SDN. So let me go back and show you. The SIM has two numbers, this IMSI and MSI SDN, right? So I'm not talking about the MSI SDN over here. I'm talking about the IMSI, that is the International Mobile Subscriber Identity. Again, that is a 15-digit hierarchical address. And again, with time, this also has got evolved, and we will not go into the detail of that. The next is the MSI SDN, right? So that is basically your telephone number. So it follows the international ISDN numbering plan, that is the international telecommunication recommendation. There's a certain format of that. And GSM is the first network to distinguish the user identity, that is IMSI, and from the number to dial, that is the MSI SDN. So obviously, most of you know what your MSI SDN is, that is your mobile phone number, but I don't think most of you know what your IMSI number associated with your SIM is, right? Okay, so the separation of the IMSI, MSI, SDN protects confidentiality. IMSI is the real user address that is never public. The faking false identity needs signal IMSI to the network, but IMSI is hard to obtain. The separation between these two numbers allows easy modification of numbering and routing plans as well. So IMSI may be associated to several MSI SDN numbers. So that is, you can say that IMSI is not a unique number to any SIM card, right? Okay, so the next thing is the components and interfaces of the GSM network. Very important. First of all, you have a mobile station, and then you are connected to a certain BTS. As I've talked about in my earlier lecture related to GSM, that your mobile station is under the operating region of some BTS, right? And the interface between mobile station and the BTS, that interface is basically known as the interface. And then a BTS is connected to a certain BSC, right? And this overall system is known as the BSS. This overall system is known as the BSS. So let me move on to the last lecture, where you saw over here, the number of BTSs were connected to the BSC, and then we talked about this thing, that BSS, right? So this BSS basically is, BTS plus the BSC. This makes a BSS, right? And the interface between the BTS and the BSC is A base, right? That's known as A base, right? The interface between the BTS and the BSC. And the interface between the BSS and the MSC, this interface is known as the A interface. This interface is known as the A interface. So you can say all the components that are between this BSS and MSC, that is the A interface. And similarly, interface between MSC and OMC, between MSC and HLR, between MSC and EIR, between MSC and some other MSC, so on and so forth. We have different interfaces that are mentioned over here, and you can see in this figure, right? So mobile station, BTS, BSC, and then we have MSC, MSCS, OMC, and VLR, and HLR, and equipment identity register we talked about earlier. So all of these things together make complete GSM system. Okay, coming back to the base station subsystem that we studied in the lecture earlier, that includes both the BTS and the BSC. So the interface between the mobile station and the BTS, as you know, is the interface, and between BTS and BSS, that is the A-base interface, and between BSS and MSC, that is the A interface over here. So over here in the BTS, so BSS and MSC, we have OSS, right? But what BTS actually does is it's sort of a transceiver that includes both transmitter and the receiver. And that basically encodes your voice, the rate adaptation for data. It provides the signaling channels on the radio interface, right? and it limits the signal and protocol processing, the error coding, and the other things. All of these things are included in the BTS. And then we have a base station controller that performs most important radio interface management functions. The radio channels allocation and reallocation, the handover management is also the duty of the PSC. So let me tell you what handover is. For example, you are under the influence of some BTS and you are driving a car, right? So you are going from, say, you are on the motorway, and this BTS covers a region of, say, 10 kilometers. You're over here and you're traveled a distance of 10 kilometers. When you go beyond the influence of this BTS, so obviously you will come under the influence of some other BTS, right? So the BTSs are connected to each other like this, like this. So for example, you're moving from here to here. So that whenever you will come under the influence of some other BTS, so the signaling of all your communication, that would then be shifted to some other BTS. So that is known as the handover. When you switch from one BTS to the other BTS, that is a handover. And you don't want your call to get dropped when you go from one BTS to the other. So obviously your desire is to get a soft handover so that your call does not get dropped. So obviously the influence or the region of coverage of one BTS obviously is like overlaps the region of influence of the other BTS. Obviously we don't show it in an overlapping mode when we show that in the diagram, but that is how it looks like, right? That is how it looks like, that each region covers a certain distance. That is usually the 1, 2, 3, 4, 5. So you can see that there are 6 edges of that. So basically the hexagonal coverage area is the right way to show the coverage area of any cell, right? Because this is the most optimized form of any allocation of any coverage area for a cell. Okay, base transceiver station BTS, you can see that there's a interface to the MS, that mobile station. It has filters, it has it is a transceiver, so obviously it has both the transmitter and the receiver. And then we have the transceiver digital signal processing, the transmission system, and then ABS interface to the BSC. The operation and maintenance functionality, clock distribution is obviously done simultaneously in this BTS. So that is usually the first thing that you see, or the thing that is most visible to you after your mobile phone in any GSM network is the BTS, right? So that is, as I said earlier in my lecture, that BTS is something that you see often, the towers, installed at the top of different buildings, right? That is basically the BTSs, right? So BTS is something that is the thing that you mostly see other than your mobile phone in any GSM network or in, your later systems, right? The transceiver radio interface functions, what it does is it does the modulation and the demodulation process. So in a sense, you can say that BTS is a complex model that performs the operation of the modulation and the demodulation, right? So Gaussian minimum shift keying is the type of the modulation that it performs. The channel coding, the encryption, decryption, interleaving, signal strength measurements, interface measurements, all of these things are basically the responsibilities of the BTS. Okay, you can see over here the maximum power associated with the BTSs for GSM 900 and the DCS 1800 systems. You can see that again it goes to tens of watts, but not in the kilowatts, right? In micro BTSs, it is even lesser than 1 watt. Okay, talking about the BSC. So as we said earlier, that the number of BTSs are connected to a BSC, right? So that obviously should have some sort of a switching matrix, right? So one BSC may control up to 40 BTSs, right? So it has a switching matrix, and it has the DB that contains the state information of all BSS. It has a BTS software. what it performs is it basically switches call from MSC to the correct BTS. For example, a call is coming uh, from outside the network. So obviously MSC is something that will come first in this chain of network, right? So from MSC, it will switch on to the correct BTS. For example, someone is calling you from a PSTN network, right? So obviously you are at a certain BTS that is installed somewhere, right? So MSC would route that to the BSC, and then BSC would figure out where that person is. For example, it is under the influence of BTS2. So that switching matrix will convert this or connect this MSC to this correct BTS, right? And that is basically the responsibility of a controller, the base station controller. The protocol and coding conversions also is performed here. The managing of the MS mobility is also performed over here, and it also enforces the power control. And then we have network switching subsystem, the NSS that we talked about earlier. It has elements mobile switching center to gateway MSC, from home location register to authentication center, visitor location register, equipment identity register. All of these things are basically associated with this network switching subsystem. It controls the call, the user management, the intercomponent communication. The SS1 signaling is performed over here. That is a type of a protocol for the communication. With suitable extension, the mobile application part, again, this is something that needs, this is beyond the scope of discussion, as network switching subsystem is a very complex thing that has a number of things associated with that, right? So we need to know what type of protocol it uses, and there are certain extensions associated with that, right? Okay. Mobile switching center MSC, we've been talking about that for quite a while now. It is an ISDN switch, performs the switching and routing functions of a fixed network switching node. Plus, there is some specific mobility related functions, the allocation and administration of radio resources. Obviously, in the hierarchy, you can say that number of BTSs connected to BSCs and number of BSCs connected to the MSC. So obviously, a very important part of the overall network, right? So the management of the mobile users is associated with that, the registration, authentication, the handover execution, and a PLMN operator network has in general many MSCs, right? So each MSC is responsible of a set of BSS. A BSS refer to just one MSC, not many. So keep this thing in your mind. So as we saw that earlier, that number of MSCs are associated with some PLMN network, right? So this thing that we have talked about right now. A very important thing is a home location register. Again, that is a one database per operator, right? So again, as I said, for example, if I'm using a Jazz Varid network, so that Jazz Varid network has a home location register, and that is a one database. So in practice, in principle, there is implicated for reliability reasons. So usually when we say HLRs, obviously you can say that a copies of that is also kept by any operator, right? So although that is a certain, you can say a one register, but the copies of that are also available. In large operator network, there may be 2+ HLR with distinct information. Although MSISD and HLR association needs to be introduced, HLR entries, every user MSISDN that has a subscriber to the operator that has that, or you can say your mobile phone is basically enlisted in some HLR, right? So all users of a network are basically entered in this home location register. So what it stores is all kinds of permanent information that is associated with you. For example, your mobile phone number, right? The IMSI, the number associated with your SIM, what kind of services that you have subscribed, if there is some service restriction, for example, related to roaming, the parameters for additional services, the information related to your mobile phone, that is the international mobile equipment identity, authentication data. All of these things are available in home location register. The temporary information that is associated to the user is also available in the home location register that is linked to your current location. Obviously, you move to different places, so the link to your current location is also available in the home location register, and that is temporary. As you move to different locations, obviously it does not keep information of everywhere that you go, but your current location or the link to that is available in the home location register, and it keeps record of the current visitor location register that we will see in the next slide, the current MSE address, the MSRN if that is outside the PLMN network. Then we have authentication center. Authentication center is associated to the HLR, eventually integrated with HLR. It has IMSI, responsible of storing the security related information related to any subscriber, right? And the corresponding keys of that. Okay. Then we have gateway MSC. Right. So we've talked about this, that number of MSCs are there, and eventually they are connected to some GMSC, and GMSC is the gateway MSC. So gateway MSC is basically needed as the fixed network switches are not mobile capable. GMSC task is to query HLR for current mobile station location. If fixed network switches were able to query HLR, direct connection with the local MSC would be available. So you can see that when you go out of your network, eventually you have to pass through this GMS, right? So this is the simple way of saying that. For example, this is a PSTN network and you want to call to some PSTN network. Obviously, your call would be routed and eventually you have to go out of your network, and that when you have to go out of your network, you have to eventually pass through this GMSC. Okay, this is the visitor location register that I was talking about earlier during the HLR. So in the VLR, that is the visitor location register, at most one database per MSC. So keep this thing in your mind. The HLR is the one database per this mobile network, whereas the VLR is the one database per MSC, right? So this is the difference between the VLR and the HLR, and it is generally the joint MSC VLR implementation. No need to carry heavy MSC VLR signaling load on network lines, but one VLR may serve many MSCs, right? So at most one database per MSC, but one VLR may serve a number of MSCs. What are the VLR entries? Every user or your mobile phone number actually staying in the administrative area of that associated MSC. For example, I'm sitting over here in the lecture hall, for example, right? So I am connected to a certain MSC, right? After the BTS and the BSC, eventually I'm connected to a certain MSC. And that MSC basically has my mobile phone number that I'm in this area, right? So note that may store data for roaming users as well. For example, subscribe to different operators. If I go out of my country, for example, and I, subscribe to different roaming services. So obviously, in that case, the roaming data or the user available in that certain MSC, obviously that data would also be there in that VLR. It stores the IMSI, MSI SDN number, the parameter for additional services, the IMEI number of your mobile phone, the authentication data, the tracking and the routing information, the mobile station roaming number, that is basically related to the calls or, roaming when you go out of your country and you subscribe to different roaming services. Then in that case, mobile station roaming number is associated with your mobile phone. So that is MSR, right? Temporary mobile station identity is also given in that case, and location area identity where mobile station has been registered. All of these information is also available in VLR that is connected to the MSC. After that, we have OSS. We have talked about OSS earlier as well. That is the network measurement and control function monitored and initiated from the operation and maintenance center. The basic functions are the network administration, the commercial operation and charging, may be related to accounting, billing, the security management, the EIR is connected to that. So the O&M function based on the ITU-T, TMN standards, complex topic, and obviously this is beyond the scope of that. You only need to know what basic things that it covers. Okay, so let's see what radio frequency channels for GSM T900 is. It uses the 890 to 915 megahertz for the uplink, that is from mobile station to the base station. and 935 to 960 megahertz for the downlink from the base station to your mobile phone, right? If you need to calculate what frequency is being used, so this is the formula for that. The frequency for the uplink is 890 plus 0, and this is basically point. This comma is a sort of a typo, but that is eventually related to the ARFCN number. So let me tell you what ARFCN is. The absolute radio frequency channel number. This is very important. It is a unique number given to each radio channel in the GSM. The ARFCN can be used to calculate the exact frequency of the radio channel with the GSM 900, 1 to 124 are used in the GSM 18, ARFCN 512 to 885 are used. So obviously you are assigned a certain channel, right? And that channel basically has a number from 1 to 124. So depending upon what number is assigned to you, then obviously you can calculate what up frequency and what down frequency is being used. For example, you are using say 890, and this is the first channel, right? 890 is for the uplink, and in that case 890 plus 45, that is the 935 megahertz, is for the downlink, right? So this is the duplex spacing of the 45 megahertz from the uplink and the downlink. For example, call going from your side to the base station and the call coming from the base station to your side. Obviously both of those signals are operating at a different frequency. So similarly, if you are assigned some other ARFCN, obviously that you would be using a different uplink frequency and the downlink frequency. For the GSM 900, the GMS extended band, we have 880 to 915 megahertz for the uplink and 925 to 960 megahertz for the downlink. Okay, for example, for the uplink, 890 plus 0.2 into n. For example, you are assigned the ARFN, the channel number of 0. So in that case, the uplink frequency would be 890, right? But in that case, the downlink frequency would be 890 plus 45 megahertz. 890, that would be 935 megahertz, right? And similarly, depending upon what channel number is given to you, you can calculate the uplink frequency and the downlink frequency. But keep this thing in mind that the duplex spacing in both of them is 45 megahertz. Right. So if you are assigned the ARFCN number, say 975 megahertz, in that case, that is how you're going to calculate your uplink and the downlink frequency. Similarly, for the GSM 1800, these are the frequencies for the uplink and downlink. The duplex spacing here is 995 megahertz, and with 374 channels, 2 kilohertz spacing. So that, again, you need to calculate what frequency is, given that you know what your ARFCN number is. This is the GSM frame structure. We have a hyper frame, then we have a super frame, a multi-frame, frame, and a time slot. And let me tell you, the mobile stations can be at different distances from a BTS. The further away a mobile station is from the BTS, the more transmission delays will cause their burst to move out of their time slots. To prevent overlapping and interference from other transmission in other time slots, every burst has a guard period at the end, right? So you can see over here, in a time slot of a UMT that is assigned to any user, we have a guard period over here, right? This G. The normal burst has 8.25 bits of the guard period. So you can say the quarter bit in here might raise eyebrows. For example, you know what? Eventually, you know, there's a 1 bit, but what is the meaning of 8.25 bits over here? Remember that we are talking about periods in which to send these bits. So from every normal burst transmission, the period it takes to transmit 8.25 bits are ignored, right? So this is basically associated with we're talking about the time slot. So 8.25 bits, the time associated with the 8.25 bits, that is basically the guard period, right? Okay, so in the starting bits, we have 3 starting bits, then we have 57 bits of data, and then we have a stealing bit and stop bits and the guard periods. So overall, we can say that we have 156.25 bits associated with a certain time slot that is allocated to any user that is using the GSM network, right? So all bursts have also have a tail bits at the beginning and the end of every transmission. These tail bits are also ignored. The starting tail bits are used to compensate for the time it takes a transmitter to reach the peak of its power, and the ending tail bits for the time it takes from the transmitter to the power down. Okay, so I was talking about the slot. The slot is the time that is allocated to a particular user, and the GSM burst is the transmission that is made in this time. So each GSM slot and hence each GSM burst lasts for 0.577 millisecond, that is 577 microseconds. Each of these burst periods are grouped into what is known as a TDMA frame, right? So this is the time deviant multiple access that is happening in a certain GSM frame, right? So in a frame, you are allocated a certain time slot, and this is how the time slot is allocated. So you can say that this is the data. For example, you're talking to someone, so this is the data associated with that, right? And number of time slots make a frame, number of frames make a multi-frame, number of multi-frames make a super frame, number of super frames make a hyperframe. And this is how the overall GSM frame structure looks like, right? So we will end over here. The next few slides, I will assign that as a homework to you guys. So thank you very much.